Database Masterclass in Notion, Relations and Rollups. Thank you for joining this Notion Database Masterclass, where we're going to talk about advanced database concepts such as relations and rollups in Notion. It's part of the 100 Days of Notion video series, and we're entering week 6 and day 36. If you have been following this from the start, congratulate yourself. This video means that you have completed more than 1/3 of the video series. Well done! Today we're gonna dig deep. We're gonna lay the foundation to talk about databases, relations and rollups in Notion. Today will actually be the first episode where we won't touch Notion at all. So we will look at databases, what they are, data structures, algorithms and how to access data inside databases, how different data relate to each other within a database, and much, much more. If this all sounds a little bit complicated, fear not, we'll try to keep things quite simple. I think it's actually a really good foundation before we start relating data for real inside Notion. It helps with the understanding. This is going to be a quite long, in-depth video. If you want to skip ahead, I'm showing you a few time codes on the screen right now. You can also use the chapters, which I try to make for every video, available in the timeline as well as in the description. Today, we're learning what a database really is and what database relations actually mean. Later on, we're going to revisit our habit tracker and the task manager and redo them using our newly learned database concepts and techniques. Towards the end of the week, we're going to build a database-driven system to track TV series. Once we reach this level, we can start calling our Notion templates full-blown apps, competing with any specialized app out there. And of course, I'll be releasing a template by the end of this week, so you can look in depth at how everything is connected and maybe quick start your own TV series database. Alright, so what are databases and what are relations? A little background here. I'm coming at this from a computer science engineer and a programmer's perspective. I have used databases for more than 20 years. The first thing to know about databases are that there are a few different categories. You can categorize the databases in many different ways, but I'm highlighting a few here. So the first one, the most important from our point of view, is relational databases or SQL databases, sometimes pronounced SQL. The relational databases are what we're talking about here and what's important to understand what happens behind the scenes when we create relations and rollups in Notion. The second most popular type of databases is NoSQL or non-relational databases. NoSQL databases really shine when we want to store large amounts of data or complex data and where we can simplify the relations. A third category is object-oriented databases like IBM DB2. We're not going to talk about them especially much here. Fourth, we have graph databases. Graph databases are typically used by networking sites like Facebook to connect graphs of data. In Facebook's case, it's graphs of people. So each node in the graph would be a person, and then they have relationships between them. There are also plenty of hybrid options out there. Postgres is one of the more well-known ones, and for each cloud there are also options such as Microsoft Azure's Cosmos DB or Amazon's Neptune that support multiple database types through the same database engine. And by the way, Postgres is actually the main underlying database in Notion. So Notion itself, of course, uses a database to make data access and data storage efficient. As I said, the main focus of today and this week is going to be relational databases, understanding them and using the power of relational databases when we create databases in Notion. We're going to use an entity relationship diagramming software or ERD software just to visually show a database structure. Today I'm going to use quickdatabaseddiagrams.com to do this. It's a software where you write some text in the left column, and you get a nice graph of the database structure in the right main area. I have started with their example here to quick start our journey, and I've commented everything out. So the hash symbol, the hashtag in the beginning of each line means comment. So as long as there is a hashtag in the beginning, the text on that line will not be read by the software. As I said, today we use an online tool. There are several diagramming softwares that support showing database diagrams. One of the best ones to actually map out your database structure, which is what we're doing here, is pen and paper. So do use a pen and paper when you plan your database structure. Great. So we're going to start with a very classical example. We're going to start with an example connecting customers and products in a web shop with the orders they place. For this, we're going to need a few tables. This is very similar to creating pages with database tables inside Notion. So we start by creating a customer table, a product table, and an order table. So now we have these three database tables, and we're going to add some properties to them, or columns. And as we know, having used Notion for a while, a database can be simply seen as a spreadsheet or a table of data. So for the customer, we're going to add 4 properties, a name property, and then 3 different properties for the address. For the product, we're going to add a name and a price. And for the order, we're going to add just a total amount, so a sum of the total order value. The second step when working with relational databases is to create an identifier column for each row in the table. So we simply call this customer ID for the customer table, we call it product ID for the product table, and we call it order ID for the order table. And as you can see in the graphical representation here, for some reason these got bolded. And why is that? Well, that is because we said that this is the primary key, the identifying column. Alright, so now we have the basic properties set up. And before we move any further, let's just very quickly address what we're seeing to the right here. There are a few different data types for properties in a database. It's very similar to the property type in Notion, where we set if it's a number, if it's a multi-select, or whatever it might be. In a relational database, a few of the main data types are strings, some kind of text, so the name of the customer, for example. We have the integer, which is a whole number, not a fractional one, meaning something like -5 or 0 or 10 or 5,000. Then we have a float, or a floating point number, which is a decimal number. So that could be 10.5 minus 100.3 or something else. Lastly, we can see that some of these data types have a question mark towards the end. Address 1 here has the data type string. Address 2 has the data type string question mark. And that simply means that the property is nullable or optional. As we know from Notion, all properties are actually nullable, so all are optional to set, but in a relational database, you need to pick if a property is required or if it's optional. So to create a new row in the customer table, we absolutely need 3 things, otherwise it won't allow us to create it. We need an ID that's unique, we need a name, and we need the first address row. But we can skip the address 2 and address 3 and simply leave these empty or leave them as null. Let's start looking at relations and start connecting these 3 things. So let's think a little bit in our head, how do these 3 tables relate? As we said in the beginning, we have our web shop, we have several different products, each have their own unique product ID. They have a name and they have a price. And then we have customers, the users of a web shop, and they place orders. Let's look back at the text here and the database structure and let's start connecting all these things. So the order. We know that each order is placed by a customer. Let's link the customer ID. Now we can see that we have a new property here. It's of type int, integer, and it's matching the customer ID property type here, which is what we expect. So the second property, the second column in the orders database is the customer ID, and that will have a number, and that will reference the customer ID of the customer that placed the order. If you look real closely here, we can see that we have a little fork here that signifies many, and on the other side we have a 1, or a little line that signifies 1. So what we're saying here is that one customer can have multiple orders. An order must have exactly one customer. So let's look at product. How could we link these? I mean, the first approach here would be to say that we want a very simple relation. We have a list of products for the order, so similar to the order and customer relationship, but the other way around. To make this happen, we go to the order and we say that we have a new property that's called products, and that's a foreign key. It's a many-to-many relationship, and it points to product.product ID. Great. So now we got a new property here. We see the fork, so we say that each order can have many products, and it's connected to the product table. That's great, but if we think a little bit about this concept, we realize that it doesn't generalize very well. So while we have our order and we can add products to it, it's just a big bucket of products. So we need a little bit more information. Let's remove this and let's add a fourth table that we call order line. So this will be the table that connects orders and products. This table type is called a union table and replaces a many-to-many relationship with a table that can contain extra information. In this case, we want to track the number of products connected to a certain order, and not just that a product is part of an order. So similar to the others, an order line would have an ID, order line ID, and a quantity, how many products of a certain type are added to an order, and it would have relations to both order and product. Great. So we have a customer, they place an order, the order contains several order lines, each order line references a product and says how many of that product we need. The last thing we could add here is order status. So have we processed the order or is it still pending? We add a new order status table. Each order would then point to an order status. So that might be that the order is placed, that the order is pending, that we're picking up the items, that we're shipping it, or that it's completed. Now we have our little relational database example, and this is something we could build in Notion. What did we actually win then when we created a relational database compared to other types of representing this data? Well, a key concept in database design is dry, don't repeat yourself. And what that means is that we want to store each data only once. And what we're saying here is that if we look at order line, for example, we can see that it references a product by using the ID. So by knowing the product ID, we can get the name and the price of the product. So what we could do instead with the order line is say that no, we don't want to reference a product. We actually want to write the product name in each order. We would like to write the product price in the order. And we would store the same data, but we would store it multiple times. So if we had 1,000 orders that orders product A, we would for all of these write the text product A, we would write the product price, and maybe that doesn't matter. Maybe you actually want to know what the price was at the time of the purchase. But it becomes problematic when you start adding more details to the product. So you might have a description, You might add an image or a link to an image. You might add a video. You might have testimonials or whatever it might be. So if you were to duplicate all of this data into the order line database, you would duplicate a lot of information, taking up extra storage, making the database slow to access, and in general, not being a great database design. So let's re-add this link. The product name we could then remove, and the product price we might want to keep, as that was the price at the time of the purchase. But now we don't have to duplicate all these other properties, a description, image, video, whatever. We have an actual product that we're referencing that is its own entity in the database. And this is something I would encourage you to do in Notion as well. For each data type you want to store, you create a new table, and then you link these with relations rather than duplicating information. Great. So let's just very quickly try to visualize here what we're talking about using Excel, so we kind of understand the structure. So we would have a customer table. We would have a customer table. It would have a customer ID property, a customer name, and some address rows. We might have Bob. So we have customer 1, 2, 3, 4, 5, 6. So it's an integer, it's just counting upwards. We have Bob, we have Mary, we have Mark, we have Bianca, we have a few customers. Bob, Mary, Mark, and Bianca. They would of course have a lot of information filled here as well, but we'll just leave this blank for now. We'll format this a little bit so we can see that this is a table. Great. All right, then we would have a products table. The products table would have a products ID column, it would have a name column, and it would have a price column. Here we have a lamp, here we have a desk, here we have a table, and here we have a chair. And they are priced very competitively at 10, 25, 40, and 80. We'll format that as well, and we'll make that green just so we can make it out. Very good. So after customer and products, we have orders. So we have the order ID, we have the customer ID, we have the total amount, and we have the order status ID. So same here, that the orders would just continue here. It would link to a customer, so one would be in Bob. He placed 2 orders here. And then we have Mary and Mark, and then Bob placed a 3rd order. We have a total amount, we can skip that for now, and order status ID, we can skip that for now. All right, so we'll format this as well, and we'll say that orders are this nice orangey color. Then we have order lines. Each order line would have its own ID, same as all the others. Order line ID. It would link to an order. So we have the order ID. It would link to a product. So we have the product ID. We broke out the product price, not completely necessary, but we chose to do that anyway. And we also have the quantity. Right? So typically we would have a lot more order lines than orders. So the first 3 might be for the first order, Then we have 1 for that order, 2 for that order, and 3 for the fourth order. Okay. For the first order, the products they ordered was 1 lamp, 1 desk, and 1 chair. For the second order, what they purchased was a desk. The third order purchased a table. Fourth order purchased a chair, a desk, and a lamp. We'll skip product price for now, and we'll just set some random quantity here. Great. For the order lines table, we'll format that as well, and we'll use gray here. Right, and here we have the order status ID, and in Notion we would probably use tags here. Tags, so a multi-select if you can have multiple statuses, or just a single select if you can have single ones. So what we would say here in Notion, and what we would see would be that this order is placed, this is pending, here we are picking the items, we are shipping this one, and this one is completed. In a database design, we would actually have a separate table that have all these statuses. So this is something you can do in Notion as well if you want to store more information than only the tag or only the name. Let's create this as well. So we create our order status table. We have the first column or property, as always, is the ID, and the second one is the name or the status. Great, so the first order status would be placed, the second would be pending, third would be picking, fourth would be shipping, and fifth would be completed. This order status ID table, we'll try to see if we have any colors left. Okay, we'll use this quite hard to read yellow one. Perfect. And then we can just replace this. So maybe the two last are just placed. We're picking this one, and these two are completed. So now we look at order 1. We know that that is completed, since we can reference that. We can also see what customer placed this order. So here we see that that was Bob that placed that. And to know what items are relating to this order, we need to go to the order lines. So then we need to look at everything that references order ID 1. So we can filter this, order 1, and then we can quickly see that for this order we have 3 items. Product 1, product 2, and product 4. So that would be the lamp, the desk, and the chair. And they have the quantity 1, 2, and 5. So if we want to track this order, order 1, and we want to say total amount, we would multiply this. So the product price, since we have a property specific for that, we could say that, yeah, the lamp at the time of purchase cost 10, the product ID 2, desk, costs 25, the chair costs 80, and then we can multiply this, so we have 10 plus 50 plus 400. So that would be 460, and we would save that as the total amount for that order, and then we would do the same for the others. Total amount in this example is actually what would be called a rollup column or property in Notion. A rollup property is simply a property that goes to a referenced table, in this case order lines, and it applies an operator. Here we're summing all the prices in the order line table. So a rollup is applying an operator to a set of rows in a referenced table. Let's remove the filter so we see everything here. Great, and this is really it. So this is the concept of relational databases and how to tie things together. Here we see the tables as you would set it up in Notion or in Excel or in whatever, but a slightly better way to show these things would be with a database mapping tool like this one. Fantastic. We'll end things here for today. It was a little different episode. We didn't touch Notion at all. We just looked into the basic concepts. I really hope you liked this one and that you'll join tomorrow. And tomorrow, I promise you, we will actually open Notion and we will start implementing these things we just learned. Do you like these types of in-depth masterclasses? Comment below. I'm very grateful for any input you might have. Thank you very much for joining and see you tomorrow. Have a nice day.